Hello everybody, welcome to the last part of my topic, that is reactive intermediates, carbene and nitrenes. From our last classes, what we have seen? We have discussed that various type of reactions associated with the nitrenes. We have seen that the reactions with the nitrenes with olefins or alkynes, that is the addition reactions that we have seen. After that, we have discussed various type of insertion reactions, that means the electron deficient nitrene species, how it can be inserted into a carbon hydrogen bond and different type of regioselectivity, that also we have discussed. Today, in the last topic, we will discuss, or last lecture we will discuss that the various type of rearrangement reactions that is associated with nitrenes. So, what we will learn today? We will learn the rearrangement, rearrangement reactions of nitrenes. So, now we have seen in case of carbenes, there are certain rearrangements that is happening with the carbene species. One of them that is very important, that is called Wolff rearrangement. In this case, it has also found for the nitrenes that similar type of rearrangements are possible with nitrene species also, and all these rearrangements there here the migration occurs to electron deficient nitrogen center. That means that one to shift of an atom or group from the adjacent carbon to the electron deficient nitrogen center, that happens, and that is quite similar like a carbenes. And in this way these rearrangements happens. Now, if the living groups due to this migrations, some groups that will be act as a living group, they will be different in different reactions. According to that, different rearrangement names came. So, if we see that for carbenes, that Wolff rearrangement, how it works, that will clear that in case of nitrene how these reactions are proceeds. One of the most prominent intermediate in these type of reactions that generates commonly is isocyanate. If we see the rearrangement in general, so this will happen in this way, then this 1-2 migration, if you see, this is the adjacent carbon, this is the adjacent carbon, and these associated group or atom that will be migrated to the electron deficient nitrogen centers over here. And overall what it will give? It will give this isocyanate species. And what we got for this nitrene species, various type of rearrangements are possible for this, basically the rearrangements with the electron deficient electron deficient nitrogen species. We will not say that these reactions are directly going through nitrenes, but in general this is going through electron deficient nitrogen species. We will see that how these reactions will work. As per example, there are 4 different type of rearrangement reactions we will discuss today. One is called Curtius reactions, next that is called Schmidt reaction, Number 3 is that Hopman reaction, Hopman rearrangement reactions. Okay. 4 is called Lawson reactions. So, Contd's rearrangements, Schmidt rearrangement, Hopman rearrangement and Lawson rearrangement, these 4 type of reactions that is associated with the electron deficient nitrogen species. So, in that case, in these 4 type of reactions, for these first 2 cases, here the leaving group is nitrogen, whereas in this case that means here X equals to nitrogen. In this case X equals to bromide, and in this case X equals to acyl derivative of hydroxyl, that means O acyl group, OCOR prime. Okay. So, these are the basic differences between these 4 type of reactions, though these are in general passing through similar type of reactions pathway, but these are overall difference for these 4 type of reactions. As for example, if we take first this Contd's rearrangement, okay. In this case the starting material is the carboxylic acid or corresponding we can say not carboxylic acid, rather carboxylic acid can be converted into the finally into the isocyanate, and which can be attacked through various nucleophiles to give the final product. As per example, all these type of starting materials that will eventually leads to this acyl azide. Okay. How these reactions can happen? That first you can treat with this chloroethyl formate, and this will give first you the mixed anhydride, okay. And then you can treat with some azide source, and that will give you this acyl azide. Okay. Similarly, this you can get from the diphenyl phosphoryl azide, that is okay. And you can start from carboxylic acid, that directly will give you this acyl azide compound with the reaction of this diphenyl phosphoryl azide. Okay. Additionally, you can start from this hydrogen derivative to the corresponding acyl azide in presence of sodium nitrite under acidic conditions, that will also give you this acyl azide. Now, this is a nice precursor to generate the desired isocyanate intermediate through this way. Okay. So, now sorry. You can draw in this way. Okay. So, okay. So, now this 1-2 migrations can happen to liberate the nitrogen, okay, and give you this isocyanate derivative. Okay. And now, various nucleophiles can react as per examples water, as per examples alcohol, and give you this can attack over here, and then finally, you will get this desired product. It could be acid, and if it is acids, then if it is water, then the decarboxylations will give you finally the corresponding amines. So, in this way various type of nucleophiles can react with this isocyanate and give you different products. Okay. Now, in these type of reactions, whether they are going via discrete nitrene species or the reaction is this migration is concerted to form the isocyanate intermediate. To know that, various type of controlled experiments were carried out. As for example, if the reactions were done in crossover experiment, then there is no mixed product formed. This proves that this reaction is not going through the discrete nitrene species. Number 2, if the reactions was carried out in presence of water, then there is no formation of this particular this one RCONH-OH. Okay. This proves also that these reactions is not forming the discrete nitrene species. So, this has not formed. Okay. So, this way you can prove that this 1-2 migration is happening through concerted manner. Okay. Additionally, it has been found that if this IR group, this is chiral, then what happens? Then if this is chiral, after migration also 1-2 migration also they retain their configuration. That means, this reaction is definitely happening through concerted manner. Okay. So, this is overall we can say that reactions is concerted process, and that has been proved as there is no crossover experiment products and there is no formation of this RCONH-OH. That shows that these reactions are happening in concerted manner. Okay. Next, we will see the another type of reaction, that is we have discussed that one initially, that is called Hopman reaction. Hopman rearrangement reactions. So, Hopman reaction. Okay. So, in case of Hopman rearrangement reactions, the starting material is amide and the end product will be amine. Okay. So, in this case, in spite of acyl azide, here it will start from the amide group and the reagent is alkaline hypobromite Okay. So, if you start from the corresponding amide in presence of hypobromite, okay, it will pick up one proton and then it will generate this intermediate, and then in presence of base this will pick up another proton. Okay. Now, this 1-2 migration will happen and bromine will be liberated, and in this case again what you will get? You will get the very important isocyanate intermediate, and then water if nucleophile, then it will attack can attack to this electrophilic center and give this intermediate, which again in presence of condition, basic condition, this will eliminate the carbon dioxide and give the corresponding amine. Okay. So, the starting material here is, in case of Hopman reaction, is amide and the end product is the corresponding amine. If you see here also, as I mentioned previously, the main intermediate that is forming the isocyanate and then it leads to the corresponding amine. So, the difference actually here is, both cases these 1-2 migrations are happening, but in case of Coutier's there is the leaving group was nitrogen, whereas here it is the corresponding bromide. Okay. Next we will see the third type of rearrangement reactions, that is we can call like a Lawson reaction. Okay. This is also similar like Hopman reactions, but only in this case, in spite of bromide, here as the leaving group is this O-acyl derivative of the corresponding hydroxamic acid. Okay. So, as per example here, if we take this O-acyl derivative of hydroxamic acid, okay, that will give the, in presence of base, the corresponding isocyanate through this 1-2 migration, okay, and finally, in presence of various nucleophile like water here, this will give the amine plus carbon dioxide. Okay. Only thing is here, the difference with the Hopman is that here this O-acyl derivative of this hydroxamic acid is the starting material, and in this case the leaving group is this one, this is the leaving group. Okay. So, in this case also these 1-2 migrations can happen to give the leaving group as the O-acyl derivative. Okay. And what it will generate from here? It will generate this isocyanate derivative. Fine. So, whatever we have seen, this Coutier's, Hopman and Lawson, they are basically the basic mechanism where this 1-2 migration is very important, as it happens in case of Wolff rearrangement in carbene. Okay. Next we will learn another very important reactions, that is called Schmidt reaction. This is more like the Coutier's reactions, because in this case of Schmidt reaction, Schmidt rearrangement reactions rather, in this case also it was more similar like a Coutier's type of reactions, because in this case also the leaving group is nitrogen. Okay. So, the starting material is either the carboxylic acid or the ester, in presence of hydroxylic acid and the different acid. In many cases it is dilute sulfuric acid, and in that case it will give the corresponding amine Okay. So, we can see that carboxylic acid in presence of hydroxylic acid, that gives the corresponding amine and carbon dioxide. Okay. So, this is the overall Schmidt reactions. In this case also the leaving group is nitrogen, and the main reaction happening through this 1-2 migrations. So, if we see the reaction mechanism, okay. So, this gives this intermediate, and once this generated, then this 1-2 migration can happen and nitrogen can liberate. So, what you will get? So, you will get this carbamic acid. Okay. So, once you will get this carbamic acid, then in acidic conditions this will give your desired amine compound. Okay. This in these mid reactions, this hydrazoic acid that can again react with the ketones also. As per example, if you take this ketone as a starting material in the place of carboxylic acid, then in presence of this hydrazoic acid under acidic medium, this will generate this intermediate, and once it will generate, then again this is now ready for this 1-2 migration, then nitrogen can be liberated, and overall what you will get? You will get the corresponding amide. Okay. So, if you start from carboxylic acid, that will give you the corresponding amine, and if you start from the ketones, you will get the corresponding amides. Fine. As per example, if we see, if it is the ketones like cyclic ketone, then like cyclohexanone. Okay. If it is cyclohexanone, in presence of phenyl azide, this aryl azide and TiCl4 as the Lewis acid, then overall what you will get? The product will be the corresponding lactam, sorry, definitely in this case the ring size will increase, because due to the 1-2 migration, as this is a cyclic starting material. So, due to 1-2 migrations, the ring member that will be increased by number 1. That means, if it is here 6 member ring, it will becomes like a 7 member ring. So, in this case one, 2, 3, 4, 5, 6, 7. So, this will be the corresponding lactam product. Okay. So, whatever we have seen, all these cases, one very important intermediate that is forming, that is called that isocyanate. Okay. And how this is coming? All these cases, this one is coming through the corresponding 1-2 migration, which is nothing but similar like in Wolff rearrangement in case of carbenes. Okay. And what happen? All these cases when this isocyanate forms, after that this nucleophile can react and that gives the desired target product. Another important aspects for all these type of nitrene associated reactions, rather this deficient nitrogen center associated reactions are like all these cases, the starting materials are in principle they are different. As per example, in case of coteous Cutia's case, this what is that? That acyl azides, that is the starting material, and the leaving group is the nitrogen. Similar like in case of Schmidt reactions also, that in presence of these carboxylic acid or ketones, they are the that will also generate in presence of these hydrazoic acids, that will give you this corresponding intermediate, which eventually will give this isocyanate, and then finally, that will give this product. Okay. And in this case, what we have found, that in this case these during the Schmidt reactions, when it is a keto compound, that gives the corresponding amides. Okay. So, these are the overall different type of reactions associated with the nitrates, and for Hopman reactions, what is the leaving group here? In case of Hopman's, the leaving group is bromide, okay. But it also passes through this isocyanate intermediate, okay. And in case of Hopman, the starting material is the amide, and after one carbon degradation, you are getting the desired product, that is the amine compound, okay. And or for Lawson reactions, what we found? In case of Lawson reactions, which is similar to like a Hopman reactions, in that case also the leaving group is the O acyl derivative starting materials, which will finally give you this isocyanate derivatives to and ready for the different nucleophilic attack. Okay. So, these are the overall different type of reactions that is associated with these electron deficient nitrogen species. Okay. Now, if we do the summary of these nitrenes, what we found? This is a monovalent nitrogen species, and this is isoelectronic with carbenes and contain 6 number of electrons. These are highly reactive and generally generally electrophilic in nature, as they are electron deficient species, and these they can be singlet or triplet, and obviously due to their electronic nature, different their electronic structure, their reactivity are different than carbenes, and it has been found that this nitrogen center, that is in triplet, that is sp hybridized, whereas the nitrogen center in singlet, that is sp2 hybridized, and like carbenes, nitrenes also gives various type of reactions like addition reaction, insertion reaction, rearrangement reaction, etc. So, overall these are all aspects that we have discussed in this course, that is the reactive intermediates, carbenes and nitrenes. We have discussed their all type of starting from their generation, their characteristics, their reactivities and various type of reactions, both for carbenes as well as nitrenes. Hope you have enjoyed this course and will learn a lot about carbenes and nitrenes. Thank you very much.